electronic device expertise in the development of disposable lab-on-a-chip systems for bioanalytical applications, including molecular and immunoassay-based point-of-care diagnostic devices. For the past 10 years, she has been pursuing the lab on printed circuit board approach in an effort to realize disposable, mass-manufacturable lab-on-chip microsystems, engaging with stakeholders across all related disciplines. Let's give her a warm welcome. Hello, Professor Moschtow. Yeah, welcome. So, can you, are you on mute?
I just unmuted. Should be able to hear me.
We'll give you the floor to get started. Could you share your slides, please?
My talk is in half an hour, right?
Actually, we're sorry. We had to move you up because there was a technical difficulty. Would you like to go now? Would you like to give your talk now?
Sure. I will have a presentation some heads up, but okay, fine. Okay. So I shall share my screen now, right?
Yes, please.
I guess you want me to get started now.
Yes, we can see your screen. Thank you. Can you make it full screen?
Yeah.
Are you interested in this topic? Is it working now?
Yes, it looks good now.
Okay.
Thank you.
Can you hear me also?
Yes, it's excellent. Please go ahead.
Okay. So, okay, this is a bit unexpected. I was not prepared to do this right now, but anyway, thank you very much for having me. I hope you will enjoy my talk regarding integrated lab-on-chip devices for biomedical diagnostics, printed circuit boards, printing, and other techniques we can use. So first of all, I will talk a little bit very briefly about who we are at BAF and what we do. Lab-on-chip technology, for those of you who are not familiar with it, what we do with printed circuit boards and why it makes sense, and a few examples of what we have been working on. So this is Bath. Bath is in the west of England, close to Bristol. It's a very pretty city. It's actually historical, UNESCO heritage protected city. Here you can see a picture of the Roman baths. And our university is quite a young but very developing university, very fast developing. We are only 50 years old, but we are growing on a daily basis. And I'm very lucky to be part of C3 Bio, which is the largest center in the UK in the area of biosensors, bioelectronics, and biodevices. We are a cross-disciplinary research center. Of course, there are a lot of people from engineering, aspects of engineering, but also physical sciences like chemistry and biology or physics. And of course, a lot of people from healthcare, even from social sciences and psychology. Our objective is to bring new technology to the world with the aim of achieving actual impact in people's lives. So we are working with a lot of major universities across the world, including Harvard University, NTU in Singapore. We've started recently a collaboration with IIT in Mumbai, and we are expanding every day despite COVID, having made a few of these collaborations a bit difficult these days. So let me fast forward to Labancy technology and what it is, and particularly why we are involved in this area and why I have been involved in this area for the past 10 years. So the objective of lab on chip technology is exactly what you see in the picture on the left. So basically to miniaturize a complete biochemical laboratory, including all equipment, sample processing, detection, even the actual handling of the liquids and the reagents that is being done by specialized personnel, shrinking everything down to a microchip of a few centimeters square. This is not unprecedented. It has happened before in microelectronic engineering when the integrated circuit was invented. Actually, a few decades ago, every computer used to take up a whole floor or a complete room until we invented the integrated circuit and shrunk everything down into a few millimeters or centimeters. The way to do that was by solid-state electronics, so miniaturizing all of the components of a circuit, the transistors, the diodes, the capacitors, and every component of a circuit. In lab on chip technology, we go beyond that because most of the reagents and the samples that we need to handle are liquid, so we need different components. We need channels, microfluidic channels that are able to transfer the liquid where exactly we want it on the microchip, microvalves and micropumps to push it and direct it exactly where we want, and of course biosensors to detect the actual substance that we want to quantify, and any kind of sample preparation components. So devices and components for separating the reagent of interest or a micromixer to make a reaction happen or anything similar. The impact of this technology now that we are all living with COVID is pretty self-explanatory, so I could always skip this slide because COVID has showed us very clearly why we need lab on chip. We just don't have enough labs. It's very simple. Even if we want to test everyone, it is impossible with the current infrastructure. The only way to do it is to give every person their own lab. The only way to do that is by having lab on chip technology. So I will just leave it at that in terms of the impact because I think it is a pretty strong case by itself. So how do we make lab on chip devices? We need the components that I told you before. There has been a lot of research the past 30 years on all of the components that you see here, a lot of progress, millions of, hundreds of thousands of scientific publications, and we have progressed a lot. However, lab on chip is not yet there. And one of the reasons why it's not there has to do with the next translational step. So how do we make an integrated device, integrating all of these components together in a mass manufacturable way? This question has not been answered yet. There have been different technologies explored, like silicon technology, glass technology, polymer technology, or paper technology. They all have their advantages and disadvantages. However, none of them is ideal. I don't know if recently you have heard about a rapid diagnostic being developed in the UK and currently going to be deployed within the next few months around a silicon device that can perform COVID diagnosis within 90 minutes. That device is based on the silicon technology that you see on the left. It is working. It has the disadvantage that I point out there. It is expensive. it will not be cheap. It will be deployed, but it will be deployed at a cost. And we believe that we have an answer for that. And the answer to that came to us through printed circuit boards. Why printed circuit boards? We believe that it is an ideal integration platform, first of all, because it is low cost. It's not as expensive as the rest of the techniques that I showed you in mass manufacturing, not in prototyping, everything's expensive. But when you want to go for mass manufacturing, PCBs are much lower cost than any of the other technologies out there. They can fabricate our devices in terms of minimum feature sizes, materials. We have proven, as I will show you later, that it is possible. And of course, because you do need electronics, you need quite advanced devices. We can't get away with pregnancy type tests all the time. Electronics is just intuitive to be integrated within a lab on PCB device because PCBs were designed for electronics. The first example of this technology when I was working in Greece, and it was a PCR device. This is quite topical, again, in the time that we are living. We didn't know this 10 years ago, but what we did at that point was miniaturizing a lab on PCB device that you see over here, DNA amplification. It's a rapid DNA amplification device. It can amplify DNA within 5 to 10 minutes with a different efficiency, but still we can have sufficient amplification even within 5 minutes. And in this case, we tried to integrate the detection to an electrochemical detector by integrating a silicon microchip. It worked, we got a nice papers out of it. However, you needed to manually integrate a silicon chip. This had a lot of problems, and in terms of mass manufacturing, at the moment, it's not really a possibility. You need to have someone to do this for you, and you will lose a lot of devices in the development time. You have a very long lead. So I started studying at that point how we can integrate on the PCB itself sensors, electronic sensors. And it seems that there were a lot of people who were doing electrochemical detection on PCB integrated electrodes. They were very early days, very few papers. So I moved to the University of Southampton at that point and tried to do that exactly. So work with the factory, not handmade devices like the ones that you showed before, manufactured in a factory locally in the UK with nothing exotic, just the simple processes that they had at the factory at that point, trying to make an ELISA test. So basically, protein biomarker quantification devices. We did. Here you can see the design for an ELISA test. And the devices fabricated, you can see them over here, also including the performance of the detection compared to the standard optical ELISA. You can see they are pretty comparable. The device, as you can see, I can hold it in my hand, it's just a few centimeters. The only problem at that stage, which was 2015, yes, that these devices were made, was the error bar that you see on the graph on the right. The PCB integrated device had a much larger error bar, so there was much more variability. So when I moved to BAF, this is exactly what I tried to address, because it was clear that it would work, but we needed to address the problem of that when you have something mass manufactured in a factory, you will have some kind of variability because of all the processes that we use. So we went deep into that, and we managed, in this case, to see commercially fabricated electrochemical DNA biosensors, assessing the importance of the plating processes that they use at the factory. You can see here two different variations, hard gold and soft gold. And we managed to get the lowest limit of detection accomplished, even until now, actually, on a PCB integrated electrochemical sensor, which is 57 femtomoles. We understood how important it is to control the surface quality, especially when you talk again about a commercially fabricated device. And right now, we can safely say that we can make the device that you see over here is basically a combined DNA amplification and electrochemical DNA detection on a single commercially fabricated microchip. At the moment that we are only ordering low volumes, each of these devices costs £2. If we go for higher volumes, so higher orders, numbers of microchips, we expect the cost to be reduced even less. At the same time, two of my students thought that it was a good idea to start exploring commercializing what we have achieved already. So a few months ago, we started selling in the first instance our electrochemical biosensors to research labs around the world. And interestingly, there was a competitor who was not us, there was somebody else also going into the PCB electrochemical sensor arena, seeing the advantages. I have to tell you that apart from our group, also Biotic, the company that my students started, and I'm also a shareholder, of course, has been very busy with COVID. There has been a lot of interest, and of course, they are running one small project regarding COVID diagnostics. You can find more details if you log into their website. We have also been involved in trying to improve further the quantification capabilities of Labancy devices by working with graphene biosensors and working closely with industry. Again, it's very good that this has happened years before, because right now that there is an emergency, we just have the manufacturing processes are there. We don't need to develop them from the beginning, but we work with the partners that we have already, and they can fabricate the devices for us. Another project we have worked before, which I think is very interesting, is CHIRP. CHIRP involved a painless glucose diagnostic for diabetics. And what I find extremely interesting in this is that we were using, again, Labancy technology, but specifically we were interested in the flexible aspects. Because in this case that we are interested in patches, the fact that we can make integrated electrochemical sensors and microfluidics on a flexible substrate actually enables that. So I'm not aware if there is any other technology available for that. So we have progressed a lot. We have fabricated the electrochemical sensor board, and we have actually proceeded with substituting the enzymes, so common glucose oxidase, with non-enzymatic sensors, so exploiting copper oxide as opposed to glucose oxidase, which makes our sensors more sensitive within the ranges that we want, and less variable, again, avoiding completely the unstable nature of enzymes. Of course, this technology again has moved forward. We're working with a startup company in London called Kaura, which in their business model, they have, again, this painless diagnostic patch for glucose, but in their case, they are focusing a lot on not on healthcare, on well-being and sports. So their customers are big football companies, Olympic athletes that want to know more about their training. So a painless patch like the one you see over there is actually ideal for their training. We have exploited this work for sepsis. I'm working in this case in collaboration with the VC Institute in Harvard. We have managed to quantify very accurately within the clinical range inflammation markers. You can see the CRP, calcitonin, and MANA in whole blood. Again, we are trying to take this further now, potentially again working with local hospitals in the UK to understand better and quantify faster inflammation in COVID patients. We haven't developed it yet, but we are working with them towards this direction. Just to give you an idea, this kind of sensors, the integrated lab-on-chip device, they can give results on inflammation markers, quantitative results within 10 to 12 minutes. Here you see some results that we have from integrating graphene sensors or transistors on top of our boards in an effort to make them even more sensitive. But this is again now at an exploratory stage. We have previously done detection of whole bacteria, so whole particles on the board itself successfully. I'm going very fast because I want to give you an overview of all the projects and all of the capabilities that this technology has. And of course, for any questions or anything you would like more information, please let me know. We have been working also with environmental monitoring. We don't only do healthcare. So we have a lot of interest again, and we are working with quite a substantial amount of companies for measuring water quality parameters. Here you see a prototype detecting simply water conductivity, but we are starting to integrate whole bacterial load, pH sensors, etc. in complete devices. And to, of course, combine them later. The nature of this technology is that it enables us to have electronic connectivity, so processing and visualization of our data on the smartphone very, very easy. Interestingly, we have been working with one of the two major aircraft manufacturers in the world. I'm not allowed yet to share a lot of information on what we do and for what exactly purpose we are working on. You would expect that in the COVID era, their interest on what we are doing might have been less because basically they are in a very difficult situation at the moment, trying to restructure. But it is actually the opposite, again, to my surprise. Because of this difficult situation, especially aircraft manufacturers are interested in taking the next step forward. So they want to innovate in technology a lot, which is why they are working for us. And since COVID, they have actually pushed further our collaboration for new devices. Again, I'm hoping in a few months I will be able to share more about what we are doing exactly, but at the moment, that's all I can share. We have been doing also models of devices. So in this case, you see a brain on chip device where we can record electrically on the board itself the signal coming from neurons. We have tried, attempted basically energy production on board and have managed to get quite good results. They were recently published. So again, if you want, I can share the more technical information with you later. We have been working with the industry a lot, as I told you. Now, unfortunately, our public engagement activities have been delayed because we need to wait until we can resume physical conferences, hopefully later in the year or next year. So I need to wrap up now. I think I'm coming close to my time limit. The technology is not complete yet, but it is ready to be deployed, and it is currently being explored, and I would say deployed at some point, accelerated a lot by the situation, that the current situation is happening everywhere. Some of the challenges on an academic level that we are facing, because despite the fact that a lot of things can be translated as they are, on an academic level, we always want to push forward. We want to see the next challenges and solve the next problems. So first of all, in terms of design, at the moment, we need to work with design software that is not custom made for Labancy. So basically, we need to work around that problem. All the specifications that are used for electronics, so we need to adapt them. So the next steps for us that are currently also being developed have to do with creating component libraries in Outlook so that and deploy them open source to all interested researchers and developers. Work with more manufacturers, because at the moment the only people who can right now deploy our technology are the 2-3 factories we've been working with. And my ambition is to have many more around the world who have the technical expertise to just produce devices. It's not that difficult, but basically it's a matter of engagement. Further disseminate the possibility, the capability of this technology, and have more people working on it. I need to distill on the information and the technical details that I don't have time to say within even a few lectures. Distill them down in a textbook and organize more training activities for lab and PCB designers. And hopefully be able to advertise and disseminate later on the successes that we are currently having with such devices. So, wrapping up, we believe that it is very important to have a cost-effective manufacturing technology for integrated smart lab on chip. We believe in lab on PCB. We are deploying it. The reason why we believe it is that the material and the process options, they are available already commercially. We have showcased many prototypes, like I showed you before, for a lot of very broad range of applications. the PCB technology requirements are very compatible with Labancy at the moment, and the devices are truly, truly cost-effective. There is ongoing work happening, having to do with standardization, further engagement, further deploying this technology, but we are on our way. And I think I'm over time, so basically I would like just to thank everyone and ask you if you have any more questions.
Thank you so much for that very engaging and topical presentation. We have a couple of questions from our students. Would you be willing to answer them? Okay, so I'll go ahead. One of our students is asking here, what do you see as the role of the lab-on-chip technology for surveillance during the COVID-19 pandemic?
Look, I talk very briefly, basically, about all the stuff that we are doing right now. So we are working on, I would say, probably two fronts, but there are more coming up. The first one has to do with the rapid DNA devices that I showed you. We can actually have, right now, the standard for COVID diagnosis has to do with RT-PCR, right? Right now it's done in central thermocyclers. Our devices are this big. They take around 10-15 minutes to give you a result, and they cost, I told you, let's say £2, but they can go much less if everyone uses them. So on one front, we are working on several different projects for different engaged parties, basically, because they all have different interests. So on a rapid DNA amplification-based diagnostic, because we think it is important, this is what we are doing. We have done DNA amplification, that's not the difficult part. As far as I'm concerned, the difficult part of the challenge is to have everything in there. At the moment, everyone is testing swabs. Swabs are not great. They are not great for the patients, but apart from the fact that they are not comfortable, they really depend on how skilled the worker is to get an accurate sample. So we need to be looking into different ways of sampling, collecting samples from patients if we want to go there. And of course, on a lab-on-chip level, we need to see how we can do this on the chip, so that we avoid, if we can have everything on the chip, everyone can do it at home. And this will change 100% the way that we are handling this pandemic. Okay. Shall I proceed?
Great. Thank you
Yes,
very
you can
much.
hear me.
I think we'll stop here. Thank you so much for all your time and this wonderful talk.
Thank you.
So your lecture will be in the next session, so you can turn off the video. Hello, can you hear me? Professor Zhao, your talk in the next session.
Yeah, yes, I can.
Yeah, so
I can hear you.
turn off the video.
Next lecture is his.
Next lecture, your lecture.
Next is
Yeah.
So turn off the video, please. Camera. You turn off the camera.
আপনি বলতে থাকুন সঞ্জয় ভট্টাচার্যের
Yeah, now our
Yes.
speaker is
Yeah.
Dr. Sanjoy Bhattacharya. So he is from Tata Medical Center, Kolkata. He did his MD, DNB and FRCB in pathology. So he is also our visiting faculty. We have a course actually that the molecular medical microbiology. He is also visiting faculty and coordinator of that course from the Tata Medical Center, and he has more than 100 publications, including 9 book chapters, and his interest is molecular microbiology and clinical microbiology, and he has received several grants from DBT, ICMR and CDC, and today his lectures will be on biosafety in the COVID-19 era, what needs to be done in not just in the clinic but also in research laboratories. Dr. Sanjoy Bhattacharya, please start your lecture.
Please. Hello?
Dr. Bhattacharya, share your presentation. Can you hear me?
In 5 minutes.
Share your presentation. Professor Zhao, can you switch off your video camera?
Just a minute.
Yeah, thank you. So, Dr. Bhattacharya, can you share your screen?
Yeah. Okay. I just shared my screen.
I will do that from this.
Where's that? I'm not able to share. Can you hear me?
I can hear you, but we cannot see the screen.
No. He is in the next sound. He is talking.
Yeah, I'm not able. It's the share button is not work in my computer.
Excuse me, Professor Chow.
Yeah.
Yeah, actually your talk is just after 20 minutes. So right now Professor Bhattacharya will be talking. So if you could kindly just be there in the audio mode. So we will mute the video, please. Mute the audio, please.
Audio and video.
And video also. So and also we will request Professor Bhattacharya to share your slides, please.
Yes. Please go click on that.
There is some technical glitch, so that's why some issues are there.
Yes, it is coming. আবার যাও এসে গেছে আবার হাত দেখা ভগবান you please announce that you please switch off your camera.
আচ্ছা ঠিক আছে স্যার
The shear.
No.
Not now.
Dr. Jao, can you
Yeah.
can you switch up your camera, video and video?
Can you see me?
Yeah, we can see you.
Yes.
Next is yours.
But next is your stop. Please, after 20 minutes.
Oh, another 20 minutes.
Yeah,
All right.
Yeah.
Okay.
Okay.
Turn off the video. Thank you.
Dr. Bhattacharya.
Can you hear me?
খালি গায়ে উঠে কি
Meeting locked. That's Mr. Das. Meeting is locked. Meeting locked.
You have to instruct from here how to share the screen. All the download. You will tell him and guide him how to share the
এখন প্রফেসর সঞ্জয় ভট্টাচার্য hello sir, good afternoon sir. Professor Sanjoy Bhattacharya, now is your session. Other than Professor Sanjoy Bhattacharya, other participants are requested to just switch off their cameras. Sir, Professor Bhattacharya. Oh, he's with him. He's talking.
কি ফল খাচ্ছে
বলে আমার তো সব অফ আছে কি করে দেখবে
That's why I'm okay.
Please maintain everything is going on.
Yeah.
Is it?
Yes.
Please.
না অডিওটা যাচ্ছে
Video to on.
sir. Yeah, Professor Sanjoy Bhattacharya, can you please switch on your camera? Thank you, sir. Sir, can you share your presentation, sir? He's not able to do that. Kindly. Dr. Sanjoy Bhattacharya, can you hear me?
He is not mute.
Sir, can you hear me?
No,
No, he is unmuted.
he is unmuted.
Well, what am I supposed to speak here?
Sir, we are getting your audio now, even video.
Can you share?
কি লেখা আছে?
Can you
Yes.
yes.
In sharing in from.
Yeah, he is using mobile device actually.
Hello, can you see the screen?
Yes, sir, we are able to speak.
You please start.
Okay, can I start then?
Yes, sir, yes, sir.
Okay,
Yeah.
thank you very much.
Start your lecture.
So we start the presentation on. There's too much noise in the background. I'm not sure whether you're able to hear me. Okay, can I start, please?
We are able to hear you, sir. Even we are getting your PPT presentation.
So you can start.
You just start,
Okay,
sir.
so
Your session is about 20 minutes, sir. Sir, mic ta unmute karo. Yeah. Yes, sir. Now you can speak, sir.
are you able to hear me?
Yes, sir. We can hear you.
We
Okay,
can see the
we
slides
start the
also. You
presentation,
can
yeah?
start now.
Okay, thank you, sir. So thank you all for the opportunity to speak, and sorry for the technical problems. But the topic of my presentation is biosafety in COVID-19 era, and what we need to be done in not just in the clinic, but also in the research laboratories. I work as a consultant in microbiology at Tata Medical Center in Kolkata, India, which is a cancer care center opened in 2019. And I thank the organizers for giving me the opportunity to speak. So next slide, please. So essentially, the biosafety in the COVID era, it's very important to understand that why it is important. There are certain things which are obvious. It is important to save lives. It is important, obviously, to save your reputation, because life lost or property lost leads to not just invaluable, incalculable loss, but it also hits the reputation of the individuals involved and the reputation of the institution involved. And it is also important to save money, because a biosafety disaster can lead to a lot of unnecessary and very expensive expenditure. But we have to realize that biosafety is not cheap. It is expensive. Biosafety is really expensive, but it is cheaper, much, much cheaper than the incalculable and more expensive things that can occur as a result of failure of biosafety. So it is incalculably more expensive to be unsafe. Next slide, please. Next slide, please. Thank you. So the previous slide, please. Yeah. So the essential requirements for biosafety, one is the administrative will and administrative control. Now, without an effective administration, no biosafety is possible, both at the institutional level as well as at the level of the laboratory, be it a diagnostic laboratory or be it a research laboratory. Biosafety also requires a lot of resources, or simply it requires money. And as I said, that biosafety is not cheap. And last but not the least, some would say that it is the first point, biosafety has to be based on fundamentally good science. So without a proper scientific evidence, you cannot really build up the framework for biosafety. Next slide, please. So let us see what are the signs of COVID-19. Now, many of these points are actually obvious and known to most of you, but for the sake of students and those who are not very used to these concepts, I would just reiterate the points once again. And these are, the COVID is caused by the SARS coronavirus type 2, which is the virus whose full form is severe acute respiratory syndrome coronavirus type 2. It's an enveloped RNA virus. And because it is made up of a lipid envelope, it is susceptible to alcohol. And the fact that your hand sanitizer works, the fact that your hand sanitizer has alcohol, the fact that it has alcohol at a particular concentration, which is generally about 70%, is related to the fact that we are trying to eliminate things like coronavirus, which is an enveloped RNA virus. The size of these particles, these viral particles, are about 100 nanometers. So essentially, if you look at a HEPA filter, the HEPA filter pore size is about 0.3 microns. So that's about 300 nanometers. So a viral particle, which is a coronavirus particle over here, is much smaller than the HEPA filter. So if somebody is thinking that we can actually filter the virus with the HEPA filter, that's not really the case. It will pass through the filter. There are other mechanisms through which it will pass through the pores of the filter. But there are other mechanisms through which actually the virus is controlled in a laboratory environment or clinical environment. The important thing to realize is that transmission of this virus occurs through droplets and contacts. So hand hygiene becomes so very important in the context of this virus. And there is increasing evidence that there are circumstances, particularly the aerosol generating procedures, where the virus can be airborne as well. The portal of entry and exit of the virus are the mouth, nose, and eyes. And if one is doing an RT-PCR based laboratory work, you need a BSL type 2 lab. And if you are doing a culture-based lab where we are actually dealing with live viruses, propagating them, multiplying them, you certainly need a BSL-3 laboratory. And there is no established treatment or vaccine currently available for the management, for the prevention of these viruses. Next slide, please. So this is actually a graph which tells you about the days following the onset of infection, how the viral load actually changes. And as you can see, as the day goes by from day 1, day 2, day 3, day 4, the viral load or the cultivable viral load actually significantly comes down. And there would be very few chance of cultivating the virus from a clinical sample, be it a nose swab or a throat swab, nasopharyngeal aspirate, or a tracheal aspirate in case of lower respiratory infection, or a bronchoalveolar lavage, if one goes by the number of days, and if we are crossing about 8 to 10 days. The CT values on the other side of the graph actually is a cycle threshold value, which gives you an idea about how much virus is available, and this is detected through the qualitative the PCR that we do for detection of these viruses. Now, there are papers to show that beyond a CT value of 34, the virus is no longer cultivable. Now, there are some people think that it is not 34, it is probably a little above that, closer to the late 20s. But it's important to realize that beyond a certain point, and certainly over the CT value of 35, there is very little chance of cultivating the virus. You may be able to detect the virus by PCR-based techniques, but these viruses have little chance of growing in cell cultures and maybe very little chance of causing clinical infection, transmission of infection from one patient to another or one individual to another. Next slide, please. So what are the infection prevention and control methods? Or in other words, what is the biosafety in the clinics? It's important to see that there are a number of methods, and these are more or less the methods that we use in the hospitals. And certainly most of them are used in Tata Medical Center, which is a cancer hospital. The first thing is a screening desk for all patients and visitors who enter the hospital, and that is done at the hospital gates. So what do you do at the screening desk? You actually do a thermal scanning of the individuals entering. So you see whether they are having a fever or not. You also take a history on a sheet of paper about the presence of cough, cold, fever, a travel history, particularly foreign travel, if any, a contact history with a positive case, and last but not least, whether that individual or the associate has had a COVID test recently or not. So these questions in the form of a simple questionnaire help us to identify the at-risk groups. Now, if any of these questions are ticked yes, then you should be having a system to actually triage that patient to a particular place where tests can be considered, and if required, tests can be done. There is also this phenomenon of social distancing, which is being propagated so widely across the world. And here, we increase the distance between the doctor and the patient, the patient and the patient, the patient and the visitor, and the doctor and the visitor, or the healthcare workers and the visitor. And the idea is that the chance of transmission of infection from a source of infection to the other is reduced when one is at a distance of 2 meters or 6 feet away from the source patient. We have also instituted the principle of having a glass partition in front of the doctor's desk. So when the doctor actually does the consultation, he or she is looking at the patient through actually a transparent glass. And this actually occurs, this helps us in having a sort of a shield in front of us, so that so that the droplets, etc., are not reaching the healthcare workers, and vice versa. Please remember also that the healthcare worker can also be infected. And the glass shield actually protects in both ways in this particular instance. We are also trying to reduce the consultation time, because according to the WHO guidelines, an exposure of more than 15 minutes is considered to be clinically significant in terms of a high-risk exposure, among with other factors like being in close proximity, that is within a meter, without having a PPE, etc. So if you actually reduce the actual physical contact time with the patient, either through a history taking through a telephone or through some other means, then your actual physical contact with the source patient can be significantly reduced. This is important in reducing the chance of transmission in both directions. So I have already told you about history taking over the phone. There is also this concept of teleconsultation, which we have started in Tata Medical Center. And the concept is same. Basically, you can do it over the phone. You can possibly do it over any online platforms. And actually, it helps you to see the patient. Obviously, there are certain examinations which are not possible in the teleconsultation, but a great deal of consultation which do not require a physical examination of the patient can be done with the help of this technique. Certainly, when you are physically examining the patient, you need to have the appropriate PPE or the personal protective equipments. Here, the two things very important are the N95 mask, and secondly, it is also the face shield or the goggles. And these are very, very essential, along with hand hygiene, to prevent transmission of infection to the healthcare worker. We also encourage the patient and the patient relatives to wear masks so that the chance of transmission is reduced, and reduce visitors. So what we have done in the hospital is reduce the number of visitors to 1 per patient, so that there is less crowding and less chance of transmission, and consultation in open spaces. Now, this is something which we have discussed, because of a lack of some infrastructural problems, it has not been possible, but it has been considered. And I'm sure that some centers are doing it. Consultation in larger rooms is also something which we have done. Not necessarily always for the patient, but also for other sort of official interactions which you have with colleagues from within your hospital, as well as colleagues from other institutions or individuals coming for an interaction. So can you sit in a large space so that you are sufficiently distant from the source? Consultation in negative pressure rooms, this is generally not done, but it becomes important if you are having a discussion with a patient who is already COVID positive. So all COVID positive patients are actually housed in negative pressure isolation rooms, and there this concept of having a negative pressure room becomes very important, so that the exterior, the corridors, the other rooms, and they have a dedicated ventilation so that the air is not recirculated and they do not actually cause infection to the others. Pre-procedure testing for COVID by RT-PCR. Now, this is being increasingly done not just in our center, but I'm sure in many other centers, both in this country and outside the country. And the principle is that COVID infections are also occurring in an asymptomatic manner. So there is hardly any symptoms, hardly any fever, cough or cold or breathlessness, which can distinguish a COVID infected from a non-infected. Now, it has been seen that if there are certain procedures which involve a general anesthesia, which involve a long duration surgery, which involve an endotracheal intubation, the chance of having a severe morbidity post the intervention is very high if somebody is already COVID infected. So the idea is that you actually screen the patient who is going to have the procedure before the procedure, and if that is negative, then you proceed with the procedure. If it is positive, you delay the procedure if it is not super urgent by about a couple of weeks, and then take it further. And test is symptomatic and exposed staff. As I said, that the infections can occur both infections can occur both from the patient to the staff, as well as from staff to the patient and staff to staff and patient to patient. So one has to remember that when the staff becomes symptomatic, they also need to be tested, not just for their own sake, but the sake of the other colleagues within the hospital and other patients within the hospital. Next slide, please. Next slide, please. Next slide, please. Now, this is a very important document from the previous slides. Previous slide, please. Previous slide, please. Yeah. So this is a very important document from the World Health Organization, which is the Laboratory Biosafety Manual, the 3rd edition. Actually, it's a 2004 edition, but it encapsulates most of the important principles that we are using even today. It obviously does not have the name of the SARS coronavirus type 2, but the principles are all laid out. And you should be, those of you who are interested or involved in biosafety, I think it is an essential document you must go through. Next slide, please. Now, this table, which I have taken, I've taken 3-4 tables from this particular document, and this is to show you that there are different types of biosafety lab. This is the first of those tables. And when we are doing RT-PCR, we are essentially dealing with a type 2 biosafety lab. You can certainly do an RT-PCR in a BSL level 3, but BSL level 3 is not required. It's not an essential requirement if you are doing just RT-PCR, if you are not doing a viral culture or manipulation of live viruses. So now for the type 2 lab, there has to be certain principles in place, like controlled access, like good laboratory practice, like engineering controls like biosafety cabinet. In type 3 labs, which research institutions like yours may be interested in, either in the near term or in the long term, It's very important that the protocols and procedures are in place, and there is not only controlled access, there is an ante-room, there is a wash facility, there is dedicated ventilation, there is dedicated drainage, and there is on-site autoclave. All these things have to be put in place. Now, I would emphasize once again that there are three circles of biosafety.
Dr.
First circle
Bhattacharya,
is about
another 2 minutes. Please complete your lecture within 2 minutes.
What is called your good laboratory practices. Now, if the practices are good, the chances of having an infection is greatly reduced. The next important thing are the personal protective equipment, and the third are the engineering controls. And the example of the engineering controls are the biosafety cabinet, the controlled access. In some cases, it is the negative pressure isolation rooms. Now, an institution may not be endowed with enough number of biosafety cabinets. It may not be endowed with enough number of negative pressure isolation rooms. So the PPE, like the mask and the goggles and the gloves, most importantly, the gowns, and the good laboratory practices, they are the rings which will actually protect you. So, and the GLP being the most important. If you do not have good laboratory practices, you may have the best biosafety cabinet in the world, you may have the best PPE in the world, but it's still not going to protect you. Next slide, please. Now, this is
Dr. Bhattacharya.
Biosafety level laboratories.
Excuse me.
And you can see, I have already told you what are the requirements. So, when one is actually building and furnishing a biosafety level type 2 or type 3 laboratory, these things must be in place. So, autoclave, controlled access, then there is the following of the GLPs, the biosafety cabinet, access to personal protective equipment, ventilation, drainage systems. All these are critically important with regard to biosafety in the laboratories, be it a diagnostic laboratory or be it a research laboratory. Next slide, please. Now, research laboratories, particularly, not much diagnostic laboratories these days, they would be involved in doing animal experimentation. Now, one is that you need clearance from the Animal Ethics Committee. Also, there are animal biosafety norms which are important. The animal biosafety norms may be slightly different from the human biosafety norms, but it is very important that you follow them rigorously in order to prevent problems to the institution, to the individual, to the animals, and as I said, to the property that is associated with this work. Next slide, please. Now, there are various types of biosafety cabinets. What is important to note is that the type 2A2 biosafety cabinet is perhaps the commonest type of biosafety cabinet that is sold in the market for diagnostic purposes and research purposes. There are other types. The important message from this slide is that when you buy a biosafety cabinet, one is that you buy it of a good quality. The second important point is that it should be of the right type and subtype. So there are essentially three types of biosafety cabinet: class 1, class 2, class 3, and there are many subtypes of it and subtypes of it like A, B, A1, B1 of the biosafety cabinet in choosing or not choosing the recirculation of the air. Next slide, please. Now, how do you know that your biosafety cabinet is actually working? The biosafety cabinet air quality can be checked with the air particle counter. And this is an example of a handheld air particle counter. I think you have to enlarge the slide to full screen. Okay. So you have to actually get a handheld air particle counter. And this handheld air particle counter would enable you to check the quality of air in the biosafety cabinet. So an air particle counter is something which the help of a laser, which actually counts particles of very minute size, starting from 0.1 microns to 0.3, 0.5, 1, 3, 5, 10. So 5 or 6 dimensions of particles of air are actually calculated instantaneously. And you can see both the cumulative count as well as the differential count. Now, this is an example of an air particle counter that we use to monitor air quality.
Dr. Sanjay, please unmute your mic. Yeah, he will call.
He's continuously talking. But it is not audible.
It is not audible. It is from mobile phone. That is the whole problem.
Okay, let's go to the next level.
Hello? I think we have run out of time. So if there are any questions, I can answer those questions, or if there isn't any question, then I can go to the last slide and show the last few points.
And sense. Can you hear me?
Yes, I can hear you, sir.
Yeah, so go to the last slide, please.
Yeah, there are slides after that.
Yeah, there are few questions. We will email you those questions. Just one question I am asking. So how glycoprotein spikes help COVID-19 to enter or attach to the host cell? So how glycoprotein spikes help COVID-19 to enter or attach to the host cell? Can you hear me?
Yeah, I think the question is that how COVID-19 virus attacks our cells. Is that the question?
Yeah, yeah.
Hello?
Yeah, that is the question. So answer. How glycoprotein spikes help COVID-19 to enter or attach to the host cell?
Yeah, there's a lot of echo. If I understood your question
Okay,
correctly,
okay,
you're really
Dr.
asking
Bhattacharya,
how
we'll
COVID-19
email
virus
you
will
all
attack the
the
host cell.
we will email you all the questions and you can answer them. And thank you for your lecture and time. Thank you very much.
Thank you. Yeah.
Please unmute one of the
Professor Zhao, can you please switch on your camera and switch just unmute yourself? Yeah, thank you, sir. And share your presentation, sir.
and share your presentation.
Yeah.
I think it's not activated for me. Could you please authorize me to note my talk? Okay.
No, presentation test ছিল সঞ্জয় ভট্টাচার্য এখান থেকে হচ্ছে now sir just you share your presentation, sir.
Yeah, that icon is not active, so your admin needs to make me active. That one, I can't share.
20 minutes.
So now Professor Zhao he will talk, and he is from the full professor at Queensland University at Australia, and he is BDS and MDS, and he started his career PhD in 2000, and he is full professor in there, and he has published more than 270 papers, journal papers, 3 books, 23 book chapters, and H index is 60, and he has been cited more than 11,000. So, and today his topics biomaterials regulating hematoma for wound healing. Thank you, Professor Zhao. You start your lecture and 20 minutes is your time.
Yeah, thank you. But my PPT, I will share my PPT.
You can share your slide.
Yeah, that icon is not active. I can't share. You see, the first is the speaker, camera, then the third one. Third one is gray. You need to authorize me to share. This is not able to share.
Not that. Next.
I can't share. It's not a word.
From the left, third one. Yes, yes.
Sir, you can see the up arrow in the bottom, sir. In the bottom, few icons are there. Wherever you can see the yes, go there. Yes, sir.
Click on this.
Click.
No, no.
No. You just come out and again relog.
Yeah.
Once more you do it. You come out and log in again.
Yeah. That is the.
You log out and log in again.
Please assist him. Please assist him. Yeah, go there and assist him.
Yes, log off
Sir,
and log in.
in the bottom, sir.
I can't share that.
Yeah, share content. If you click there, sir.
Yeah.
So
Well, you haven't authorized me to share. Previously,
yes,
I
sir, the
can, but
permission
this
is
one
given,
you
sir.
can't.
The permission is given. Sir, do one thing.
No, it's
sir,
blocked for me.
Sorry to interrupt you, sir. Just disconnect and connect again, sir.
Disconnect? Okay.
Sir, you disconnect yourself, sir. Totally, you log out from the session, sir.
Okay.
Log out and
Uh,
and asking you log in again. Log in.
Now you can listen.
no, you cannot listen.
Now you cannot listen. Only after he logs in, anything can be said.
Exactly. Then Nishan can call.
No, the permission is given, sir. You should able to share that.
The things are moving. This yes or no. No, but it is going a bit bad.
Yeah.
Please come.
Yes.
Now you can try.
Now
Sir, once again you try, sir, in the same way.
Third button. Third arrow.
In the bottom, sir, you can see some icons. From the left, third icon, you just press it, sir.
I'm trying.
Arrow.
The third icon, sir, with the upwards arrow.
I just sent a video.
Beside the camera icon is there, sir.
Yeah, I can see that. That's what I'm going to share the screen.
Yes, sir. না এই অ্যারোটা আমাদের
For display will be coming a share.
No, sir. No, he's trying, sir. Definitely he's trying.
He's trying. Yeah, he's trying. Definitely he's trying. You're writing that third section.
Sir, what message is coming, sir, on your desktop? What you are seeing exactly?
I click the share your screen, then the application screen, that's nothing fine. Here. You see the share entire screen, publication.
Yeah, now it's coming, sir.
Just wait.
Can you guys see anything?
It's coming.
No, maybe.
It's a big file probably.
No, again it's disconnected, sir.
Yeah, disconnected. It's,
Try again on the top.
Sir, try again to share your PPT, sir.
but that share icon is not working yet.
Email. Just ask.
Sir, can you send the PPT in the mail, sir?
Previous one, I can try, but it's very big one.
Okay.
It's big file.
He's
I can try my another computer, see what happened when the computer.
Okay.
ও অন্য কম্পিউটার ট্রাই করছি।
Can you hear me?
Sir, can you send your PPT in the mail, sir?
I can, yeah.
We can pass it through, we can download from Spark email ID.
Sir, you are having a Spark email ID, you have to share in that only.
Okay, I will send the email.
দেবশ্রী ওটা দেখো তো ও মেল পাঠাচ্ছে।
Something a blog. Yeah. Unable to download this one. It's too big to email.
Okay.
What they say is
Sir, just
not available, maybe port 9000 and TCP 80 are blocked. What's that? TCP 80 are blocked. So I can't share that.
I asked him, sir. He's saying that something is logged like that. I'm not understanding what it is.
No, email.
Sir, can you send the PPT, the Spark email ID, sir?
Sorry?
Sir, you send your PPT presentation in your Spark mail ID which has given you.
I just send that, but as I said, the email.
Yes, sir.
My PPT is too big to send.
Okay.
To be sent. It's it's too large. I can send.
Sir, convert that in PDF and send it.
A PDF format.
Yeah.
I can convert that to PDF. See how big it is.
স্যার ওনাকে শেয়ারের পারমিশন দেওয়া আছে তো কোনো কারণে হয়তো বড় ফাইল বলে বোধহয় শেয়ার করতে পারছে না বা এরকম হতে পারে। পারমিশন তো দেওয়া আছে শেয়ার করার।
ম্যাকবুকে কিন্তু বিষয় না
প্রবলেম সিস্টেম কম্প্যাটিবিলিটি
ল্যাঙ্গুয়েজ চাইলে তো আমার মেয়ের আছে তো প্রায় মানে যুদ্ধ করতে পারে।
Professor Ziao, can you hear me?
Yeah, I can.
So, if you have any Gmail ID,
The
and you
Gmail.
any Gmail ID do you have?
Because-
Do you have any Gmail ID?
You please switch on your audio.
It's on. It's on.
Now
Professor Ziao,
I send it at the email using
if you have a
PDF format. How about PDF format? I can.
PDF,
I can send a PDF format.
yeah, please send it.
Send that? Okay.
Please send the PDF.
Yeah, I send it now.
some Gmail you have to do.
And in the meantime, you do another thing. Excuse me.
Yeah?
In the meantime, if you have any Gmail account for you, do you have any Gmail account?
Yeah, I got a Gmail.
You have Gmail
I don't
account.
have your Gmail, right? You
No,
only
no.
use the Gmail this time.
You sent via your Gmail account. You send the file. It will come as a link, and we can
Okay.
download it.
Okay.
Yeah.
Yeah, I do. I use my Gmail.
Yeah.
then.
Via
Yeah.
the Gmail, if you send, it will come as a link, which can be downloaded by us.
Okay.
Okay.
All right. I will try my Gmail. Yeah.
In between, let's do one thing. You just, let's start this,
Just in between,
person order. You just tell him, let's do the process. We are holding another one, after that again we will reconnect. Once we are getting the.
Shall we ask him that
we will
stop for some time?
we'll wait for another 10-15 minutes.
Let us have the next one.
Okay.
Meanwhile, he will do all these things.
So, Professor Ziao.
Okay,
Okay, it has come. It has come. So we are downloading.
Yeah, that's PDF format.
Otherwise, will you mind if we can postpone your talk for the next, and we can have another talk now?
No, it's okay, just come so.
Okay, you want me to talk with that PDF format doc file, the PPT?
No, okay, fine, wait.
For 2-3 minutes.
2-3 minutes, just 2-3 minutes wait, and we will start your talk only.
Okay, yeah, I can talk with the
Yeah,
use the PDF format.
Yeah,
Yes.
just do
Could you help me load the put it in my PowerPoint? Okay.
Just 2 minutes more, and we will be ready.
মেনুতে আমি আজকে ভাবলাম যে না অত মায়া করে লাভ নেই
Okay.
প্রফেসর ব্যানার্জি যে আজকে সব কিছু দিয়ে দেবে
Can I start now?
Once, no? He has to tell next slide, please, so that they will go to the next.
Professor Zia,
Yes.
so your file is here, it is being displayed. There will be introduction to you, and after that you will start.
I already
yeah, already introduced. So whenever you say, we will change the slide.
Okay, I will.
Okay.
Yeah. All right. Thank you.
please start your lecture.
Yeah. So can I start now? All right. Can you guys hear me?
We can see you. Start.
Yeah. Great. So I will start now. I'm Yin Xiao from Queensland University of Technology in Brisbane, Queensland, Australia. I visited your university, your campus last December. It's very nice. I got a very good impression on your campus. This time, thanks for the invitation, especially for attend this conference and to share some of our research in the field. Hopefully, I know that is most of the topic. You guys are talking about the technologies related to the COVID-19, etc. But in general, we are all working in medical field. So either you prevent either the infection, tissue repair, regeneration, and aging, and anti-aging, etc. That should be the common goal in the field. So my topic, what I would like to share with you is the biomaterials regulating the hematoma for wound healing. Basically, why I'm like to talk about that is because we use all sorts of the biomaterials nowadays to repair either the damaged tissues or treat, such as even once you get the infection, it's the same. You will need to use a lot of biomaterials for the treatment. The biomaterial we know play an important role in the body, especially in the early impact on the early healing process. And we all know once your body damaged, you will form a hematoma, right? Even the blood clot. So that's the topic I would like to share with you, how the blood clot hematoma formation, how that hematoma in the effect in the early healing process. And once you have the biomaterial involved, how this healing process being impacted. So I would like to use the most common body defect model, such as the bone defects, because that is nowadays still a major challenge to regenerate the damaged bone tissues in the body. We all know that due to the trauma, infectious disease, cancer, etc. The bone always damaged. How to repair that is still a big challenge. So we know that during the bone healing, the first stage is the body will form a hematoma or form a blood clot. Right, that's the first picture I will show you. Here, I've shown you. That's the form, and there's the hematoma formation itself have number of the functions. You may understand that body first would like to protect you, which is prevent you lost the blood, then to form a blood clot. Yeah, that's the first function. But in the meantime, once the blood clot has been formed, they actually form a tissue healing scaffold. So it's very important actually in the later stage when they go into during the bone formation, for example, how to form the soft callus tissues. Later on, these mineralized become a hard callus tissues. and then the remodeling process will follow. That's related to the function of the bone, which is how to support our bone tissues. Sorry, I forgot that's change the slides to the you changed it already, right? Then turn to the next slides, please. Yes, I'm not sure what I'm looking at. No, I think, yeah, going too quick because I mixed up because I have double screen. I was using my PowerPoint. Sorry, could you put it back to the third slide, number 3? Yeah, too quick. Yeah, going back. And yes, here, yeah, that's okay. Yeah, then we know that this slide is basically talking about how the blood clot form, right? Because once you damage the body, then it will trigger the extrinsic coagulation system. So there's don't need to talk about all the details, but you studied medicine, you know, number of factors will be activated. In the end, they will activate prothrombin, become to the thrombin. And the thrombin is working with the fibrinogen turning to the fibrin. Yeah. Then that's how the whole process regarding the blood become to a blood clot, which is a liquid form become a solid form, right? Then they can prevent you lost the blood and also form the early healing, tissue healing scaffold, basically. That it is. Then we know that in that healing hematoma, in that stage, what sort of things is inside this healing hematoma. So they have the cellular component, a lot of blood, red blood cell, white blood cell, and platelet, etc. They also have a lot of plasma proteins. And more importantly, we know that that's the impact on different people, which is the cytokine. Because all those response, including you have the inflammatory cytokine, also inflammatory cytokines, depending on the size of the defects, age of the defect of the patients, as well as the physiological condition of the patient. For example, if a patient have diabetes, then their cytokine will be different when they form that one. So that is what it is. They form an early tissue healing hematoma. So that hematoma determined later of the whole healing process. So next slide, please. Then in summary, early healing hematoma, they actually contain a number of things. One is they contain the fibrin, they form the fibrin, red blood cells, activated platelet, and as well as number of growth factors and the cytokines will be all inside that healing hematoma. Next, please. Then a number of studies also find out the hematoma actually have different forms. That will play very importantly in the later healing process, impact on that. People try to change the structure of the hematoma by using different concentration of the thrombin. So we know that thrombin play a very important role in the fibrin's formation. So you either use the high concentration or even the lower concentration, then you change the structure of the hematoma. They actually, what they do, they delay the healing process. So your tissue, forget that apply to the skin, to the bone, is the same. So if the normal case, you heal very well. If you change the concentration of the thrombin, you can change the structure. Then in the end, the whole healing will be delayed. Actually, they cannot form timely lead tissue formation. So that's people find out actually the structure, including the thinner or the thick of the fibers. Actually, they play a very important role in the angiogenesis and also the healing process. So next slide, please. Then that is a kind of people did the work and also summarize the structure-wise what's that the hematoma or the structure of the blood clot, what it look like. They can have a loose structure with a very thick. Basically, if the fiber is thick, then you will form a relatively loose structure of the hematoma. If your fiber is very thin, then you will form a very compact hematoma. And in that sense, is your fiber is the same, then the porosity of the hematoma actually is much less. So that is the structure-wise what the relation between the fiber size and the density of related to the density of the fiber and also porosity later on related to the porosity. So people talk nowadays in the regenerative medicine side, people talking a lot about the scaffold. So either you fabricate the scaffold in vitro, in vivo, etc. Yeah, people try to use that. Actually, in the body, the best scaffold is a healing hematoma. So they give a lot of signs that will tell you what the structure should look like, what the porosity should be, because that later on can determine the cell, especially the stem cell, the movement inside the hematoma, and also for the tissue formation, play a very important role. Second, I will talk later, that kind of structure difference significantly impact in the lysis of the clot. So because we don't want the clot to stay in our wound healing site for a long time. They only need to be there for a short period of time, but then needs to be lysis, then needs the tissue replacement. So next slide, please. So that's when people study in that field, actually they find out a number of things can determine, as I said, the importance of the fiber. So whether you can form a thick fiber or a thin fiber, number of things play important role. So fibrinogen, as you mentioned, and also the thrombin concentration, the pH level, and also the ionic strength, and also some of the other proteins is related. So people know a number of factors play a very important role in determining the hematoma's structure, while they change the thickness of the fiber. So there's some study in that field. Already that is the information people already know. But the detailed information I will talk a little bit later. Actually, is more interesting field how this can be regulated and how they impact on the tissue healing and regeneration site. I will show you a little bit later. So that is already what people studied already know in this field. So going to the next, please. So in the material side, clearly very NASA study have a focus in that. As I just mentioned previously, it's such an important early tissue healing process. And a number of factors, as I just mentioned, structure-wise, they determine the stem cells movement, their degradation, they combine a lot of growth factors, therefore they can control release the growth factors. However, interestingly is any materials, when we place that in the human body, the first interaction of the material will be the blood. So all the material first interaction with the blood. Then clearly on the surface of the biomaterial and the clot formation on the material surface will play a very important role. If you want, for example, if it's an implant, here that's the slide I'm showing you is a lot of people are doing the dental implant. You know that dental implant that more and more people are using now. And people know that a rough surface is better than a smooth surface. So machine surface, which means it's a relatively smooth surface, yeah. Then you compare that one, you have a sandblast, you have a rough surface, either the nano micro surface, and also different morphology, roughness, and their wettability, etc. They play quite an important role in regulating the blood clot formation, the whole coagulation process they play. So that's some of the evidence people find out they play a very important role. So probably in another way to explain why the rough surface in the clinic is healed better for the bone and also can stimulate the early osteointegration. They are related probably in the early stage of the healing process, which is impact on the hematoma. So that's one of the evidence. Talk about the materials later. They do play important role on the hematoma formation. Next, please. Then similarly, this also the implant. And some of you, if you're working if you talk with the dentist, you know that the dental implant originally when they invented, they need to place in the body, place in the bone, in the jawbone, and then leave for half a year. Then you put your crown. But nowadays, no. Nowadays, you only need to put, for example, 6 weeks. You can start to load your crown now. Why those things happen is people find out the surface. You can coat the surface. You can put different roughness of the surface. You treat the implant surface. You also using some chemistry coating. So that can change the surface property. And once you change that property, then they integrate much better with the bone. So that's what people know, which is if you're doing animal work from the human trial, you will know that working very nicely. Then why those things work, actually, there's a number of studies. Either people study direct with the bone. Another side is people also find out they significantly, if you put different chemistry on the surface, you can actively change the surface interaction with the blood. You can change the early hematoma's property on the implant surface. And then later on, because of that property, that accelerated the bone formation. So that's the people know the importance of the hematoma and also material surface. Next, please. Then some of the evidence I would like to show you is regarding the hematoma's structure, how the impact of the bone healing. So we did some of the work, which is using the tibia. You can make a hole defect. So you can drill a hole either 1 millimeter or 3 millimeter. 3 millimeter to the rat actually is a very large defect. They heal, but significantly delayed compared with the 1 millimeter healing. So that's the evidence. You can see that the 1 millimeter have a very nice bone formation. They have a lot of bone tissues under the micro CT. You can see the difference. And the 3 millimeter, very less bone formation. Even in the 4 weeks time, you still compare with the 1 week, compare with the small defect, it does significantly delay the bone formation. So next, please. So when you look at the early time point, if you look at, okay, I drill a hole, then in 1 week's time, you can take that clot out. Or 3 days time, you can take those things out. Then you start to study what's the difference between those good healing bone compared with delayed healing one. Then you can see there's a dramatic difference between the fiber size and the clot structure. And the porosity are quite a big difference. So you can see that it's actually the fiber size in the healing bone defect model, they are much bigger compared with the delayed healing. And similarly, the porosity, is in the healing one is much better. And also the density, because the fiber is much small in the low healing one, so density is much higher in that one. So that indicates is the early structure play quite an important role in the healing process, that especially in the bone. Probably similar, I can say quite similar when you study the skin wound healing, could be also similar. Next, please. This going to the last. Next, please. No. Yeah. Oh, no. Next, please. Next. Yeah. Then another, no. Back one, please. Yeah. This also showing you is actually not only that the structure difference will be different, their inflammatory cytokines are also different. So delayed healing have a much higher inflammatory cytokine expression. So that also say it's quite related, right? Because inflammation you need to control, tissue can heal. So in that I also show actually in that hematoma, the inflammation factor like IL-1 is much higher. Next, please. Yeah, then this is explained. So in the early, why I'm saying that is important for the people to study the hematoma, especially in the biomaterial. Once you use the biomaterial to accelerate the healing, you need to study that. This is tell you is in the early or once you have the material in, you will change the inflammation reaction, the tissues. And the inflammatory cytokines, they play a very important role in regulate the fibrin formation. The fibrin sites are all impacted. So that is basically, I don't need to explain more in detail. So I show you is different level of the cytokine you put in. The fibrin size formation are significantly different. So which means it's quite important in the fibrin structure. Next, please. So that's give you directly image. You can see that, right? Once you get a higher inflammatory cytokine IL-1, the level is high, which is more inflammation type of things. Then you can see that the fibrin, in the fibrin size, to become smaller, thinner, become more compact, and the porosity is much smaller. So that means indicates is actually the cell very difficult to move into this this clot. Yeah, next please. So that's also talk about it. Not only that it will be changed because of the structure change. So all the mechanical properties, the strength, compaction, this all the clot will be changed. What I mean is, I will tell you, because of that one, those mechanical properties also change. So they need later on the whole degradation and the lysis of the clot also will be changed. So next, please. So you can see we're doing a lysis study. So if you said you change the clot property and the inflammatory environment, you can use different inflammatory environment, right? So you have more higher level of IL-1 in the clot formation during the clot formation, and then after you doing a lysis study. So what you can see actually they much difficult to be degraded. So which means when you have a tissue damage, you form a clot, and that clot actually stayed a much longer time. So they play important role they prevent actually the healing process because they need timely to be degraded. So you can see that. So they'll change the property, change the mechanical property of the fibrin clot and also the hematoma. In the end, they also let them degrade much difficult to be degraded. Well, another thing, what they mean is, because during the formation of the hematoma, as I said, they have a lot of growth factors being released from the tissues. They're binding on the surface of those fibrin. So the timely degrade of the clot is play a key role because they control the release of those growth factors. So if they can't degrade it, which means growth factor cannot be timely released. So next, please. So that's also the degradation study. One is we show you the fibrin, the size and etc. And also that is also directly doing the measurement of the D dimer, which is when they when they degrade, they will release the D dimer. So you can see another evidence is talking about the structure, the relation between the structure and the degradation is quite correlated. Next one, please. So in those previous study basically talk about the importance of the hematoma, the structure, which is very important. There are a number of the factors play a key role in there, especially in the early healing stage. and also indicating the importance of the growth factor, the biomaterial surface. They can impact all those structures formation. And one of the reasons is because they can significantly impact the early inflammatory reaction. And the inflammatory reaction also co-worked with those hematoma formation. And because of the change in the structure, that degradation significantly impacted. So next, please. So what we do next is, so you said if in the biomaterial field, we definitely need to develop a material or material surface, or while the control release of some of the using some of the chemistry methods, or some of growth factors or some factors can be delivered, we can actually manipulate the whole coagulation forming process. Then you can form an ideal hematoma in the defect area, especially when you have the biomaterial use. So one example we use is using GSNO, because GSNO play a very important role in regulate the coagulation process, which is, people know that they also interact with the platelet interaction. So we use that one, use the similar model I just talking about, which is 3 millimeter diameters defect. They actually, as I showed before, the significantly delayed the healing. So we said, okay, whether we can load different GSNO and in the material surface, and then we would like to see whether they play an important role in the whole healing process. So next, please. So what we do is we have different concentration of the GSNO being loaded, including 1 mm till to the 10 mm to all the 0.1 mm. So different concentration has been loaded. And we, in the early stage, when we drill a hole, that's the femur from a rat. So you drill a hole, then you take the blood formed on these kind of conditions. Then you can see the hematoma's structure are quite different. Yeah, the size, the fibrin size, the porosity are all different. So next, please. So what we find out in the end is you can manipulate the coagulation process while the change of the hematoma structure. You can actually control the healing process. So we find out 1 mm loading of the GSNO can significantly accelerate the healing when you compare with the others, which they have significantly delayed. So you can change that. So what I try to say in these studies, hematoma is important, and the number of factors do play the role, depending on also that depending on the physical properties. But while the materials play, all the surface material itself play important role, then you can, through the loading some of regulator factors, you can change the whole healing process. So that's one of the evidence actually showing that. Next, please. So in this one, we would like to summarize that is actually the hematoma can be manipulated, and while the manipulation, especially in the material field, in the biomaterial field, if you develop a biomaterial, you can the loading of some of coagulation factors to regulate the early process of the hematoma's formation. Then in the bone side, they clearly can control the bone healing, especially can accelerate some of the bone healing process. So next, please. So another approach also people currently are doing actually is you can actually prefabricate your materials using the blood. Well, that can control the structure, because by understand the importance of the one, so that is another approach people use.
Professor Zhao,
please.
So please finish your lecture within 2 minutes.
Yeah, so we will actually finish. I can talk about the approach. Next, please. Next. Can you put the next slide? Yeah, so that's in conclusion, right? In summary, because I'm talking a lot about the importance of that one. topography, chemistry, wettability, roughness, and also the hydrogen. I haven't talked about that, but we are working on that, and etc. So all those play a very important role in the hematoma, impact on the hematoma's formation. And if you can form an ideal hematoma, they can significantly accelerate the whole healing process. So that's the conclusion of the talk. So the next slide is the acknowledgement. Yeah. And in the end, I would like to thank the team for working on that. So some of the image is actually the fibrin clot formation on the platelet and the blood cells on the biomaterial surface. So thank you. Thank you very much.
Good job for your nice lecture. There are several questions, but due to time constraint,
I'm not sure whether the talk has been delivered clearly, but anyway, it's online.
okay. Okay, we'll send you the questions and you can answer. Okay, thank you for your nice lecture. Thank you.
Thank you.
Next. Please, Professor Zhao, you can turn off your. Okay, thank you. So, our next speaker is Professor Suranjan Panigrahi. So he is from Purdue University, and Dr. Panigrahi is a professor at Department of Electrical and Computer Engineering Technology at Purdue University, USA. He has 20 years of experience, comprehensive experience in research, teaching, and outreach and administration. So he has a lot of experience. He has published several papers, and he first area is bioimaging and sensing center, and today his lecture will be on a strategic perspective for interdisciplinary convergent education and research to address global health issue. So Professor Panigrahi, please, 20 minutes. 40 minutes? So your talk for 40 minutes, sorry.
Can you hear me? Hello?
We can see and we can.
Can you hear me?
You.
We can see your slide also.
We can see your slide also.
Okay. All right. All right. Thank you very much for the introduction. Okay. Thank you very much for the introduction. Appreciate this opportunity. Thanks the organizers for this conference. And I welcome all the participants, audience from different places here. I am here in the US. It's early in the morning. I am taking little departure from the mainstream of the discussions going on in the conference. I am focusing on a strategic perspective for interdisciplinary convergent education and research to address the global health issues. Myself, Suranjan Panigrahi. My co-author is Dr. Edward Lichi. He is a physician and a researcher at Indiana University School of Medicine in Indiana. He could not be with us at this particular time. He has prior commitments at work in the hospital. So I am the only person who is going to present. At this particular time, we'd like to look at global health at this particular time when pandemic is affecting all of us. We realize that health is wealth. It's an old but wise saying. The Lowest common multiplier, we think is that individual health in the context of global health. And in today's global health world, the health and wellness are closely linked. So when we mention about health, it implies both health and wellness. If you look at the diagram on the right side of the screen, we have developed a diagram of hierarchy and connectedness that individual health will affect your family health and also linked to local and regional health, and subsequently it is also related to national and global health. So this concept is also supported by another paper written by the Bigelhol or Bonita. They have also mentioned that every aspect of individual health is, and their connections to the global health. When we talk about health, we also talk about the disease, the disorders. World Health Organizations have listed the top 10 diseases that are associated with the most deaths. So this information on the slide is given from 2016 data. If you look at it, let's kind of look at it from a perspective, from a benchmarking purposes. From the global perspective, heart and stroke diseases contribute to around 30 million people's death. Okay, and COPD is a chronic obstructive pulmonary disease, contributes to another 3 million deaths. The lower respiratory infections death, which is a communicable disease, is another 3 million deaths here. So when we move to the United States, I am here from the United States. I wanted to give you a perspective here. So similar data, it does not contain all the top 10 diseases in this slide. We just picked up two, the heart and COPD and the stroke. If you combined it from 2017 data, this contributes to around 793,000 plus numbers of death. Considering the COVID-19 and its association, we looked at this data to influenza and pneumonia is 55,000 deaths. Okay. So now we go back to India. I am originally from India, and my home is very close to IIT Kharagpur. And I was once upon a time a student at IIT Kharagpur too. So I thought, okay, let me take a look at India. So the top 10 diseases causing death in India with 2018 data, which is published in the CDC information. If you combine that, the heart, the chronic obstructive pulmonary disease and stroke, they basically take the first three positions. I didn't put the number of death here, but I just put it the top three positions. Then let us look at the other diseases below that. The fourth position is a diarrheal disease, which is an infectious disease, mostly caused by pathogen through waterborne or foodborne. Lower respiratory infection is fifth, and tuberculosis is sixth positions here. Okay, so from this perspective here, from the global perspective, from USA and India perspective, we got a position. So which diseases are causing how much losses in terms of human lives. Okay, and so here what happened? Okay, so today, because of COVID-19, the recent pandemic, as of yesterday, August 8th, 2020. We have this death due to COVID-19. The global death is around 723,000 people. The US, it is 160,000, 162,000 plus number, and India has 42,000. Of course, the number is increasing as we are looking at into that. And so when you look back that 100 years before, you had pandemic for 1918-1919 pandemic, and that was a big pandemic which affected many countries in the world. That had 50 million people in that 2 years because it has multiple waves of these pandemic. So this kind of gives us a perspective that what are some of the diseases which are of importance, and also how this pandemic, which is an infectious disease, is playing a role in the terms of the statistics. So, so in here, we agree that COVID-19 has caused a tremendous toll and unprecedented losses. When it first came, there is, of course, no established cure, and so multidimensional efforts got started for prevention, for detection and diagnosis, and of course, cures are also involved in that. And as part of the prevention, if you see that some of the audiences are using that mask and variety of other hand washing, social distancing, those are all prevention measurements. But for detection and diagnosis, other devices started coming in. So it posed a significant threat globally, and it still is a threat. So from the sake of this talk, we wanted to see, okay, if when we see this pandemic has taught us many lessons, and we are learning also, should we modify or change the education and research process or pathway we are doing currently in a general way to address the global health issues. So one answer could be, well, we will continue the way we are. The question here I want to emphasize is that it's modified. We don't have to change totally to be modified. Okay. So the question we propose, and the answer from our perspective is yes. And some of you might or might not agree with our proposition, but this is the theme of our presentations. We will discuss. So our goal here is, we are proposing how can we adopt a system-based interdisciplinary convergent approach for education research to address these global health issues. In this discussion, we are primarily focusing on engineering and technological disciplines, because there are so many other disciplines, it will be out of the scope during this time of the presentations. And we are only looking at bachelor and master's and PhD level component, not before the bachelor degree level. And we are looking at the education and research mostly at a very complementary level. So if you take another look at the healthcare domain, you all agree that it's very complex and it cross-cutting multiple disciplines. When you look at the healthcare domain, I am looking at from the disease and that management perspective here. So it is very important to look at, in this perspective, in this era here, the infectious disease. We are focusing on infectious disease. Many of those concepts will also apply in general to other diseases. But infectious disease is something which can create a huge impact within a certain period of time, very small period of time. And as you looked at it, that 70% of the emerging or re-emerging infectious disease are coming from vector borne or from animals. And this is a very interesting statistics because many people don't realize that. Okay, and as of the research, if you look at this in this pandemic era, lot of research are coming every day basis. So this particular research, which is here by this group from Dobson, it's a Science magazine article. This July, I think it's a July month article, is saying 2 viruses per year. 2 viruses per year comes from animal host to human host. And most of this transmission is this interaction of human with the animals. And you must have heard many of these articles, how this COVID-19 came through this meat market, and all these hypotheses are there. Many propositions are there. Many papers have been written for validation of this proposition hypotheses. So we are not going into that, but the key component is that this is the transmission pathway. It is important to know what you call in the disease sector is the pathobiology, the etiology, the epidemiology, and this is the transmission pathway where we need to know what is happening. It's so for that perspective, the complexity of the scenario forces us to look at that this new concept. This is not exactly new, but relatively new concept of One Health initiative. And I don't know whether, I am sure you must have heard about One Health concept. It basically is telling that you look at all this pathway, this value chain from where it is coming from till we reach the human being. So it integrates both the human and the veterinary medicine with other environmental and ecological domains like air pollution and all the other, different parameters in the ecological and the environmental domain. We have the website. If you are interested, you can go into that perspective. So in the global health domain, an important segment of contribution from the engineering and technological disciplinary perspective is the medical devices or systems. So medical devices or systems have many different way of classifications, class 1, class 2, class 3, class 4. I am not using that classification. In these classifications, what I am taking is that one of the most important part is diagnostics and prevention. And then you have the therapeutic or monitoring, then there is assistive or rehabilitation purposes. So in these, as the conference focuses on these healthcare technology after this COVID-19, we want to emphasize that if you recall that how long it took us to develop different type of diagnostic devices to detect coronavirus COVID-19, there are many variety of diagnostics are there, antibody, antigen, RNA-based. So we emphasize that the diagnostic and the devices can be used both for prevention and for the diagnosis, and there will be tremendous demand for point-of-care diagnostic. Point-of-care diagnostics defines as the diagnostic devices that can be used at the point of the care, in the clinician's office, near the bed of the patient. Also, at the home-based, point of use. Sometimes the diagnostic devices does not have to be a confirmatory diagnostic devices, just like a pregnancy kit. It can be used at home, but it will not be confirmatory, but it can give you an initial screening. So somewhere we can say that it's a point of use screening or at the home care, at the home level, at the individual home level, at the family level, somebody can use it. So these are the things, important things, which will be very, very important. And from that perspective, we look at that engineering design is a framework for device design. All of you who are from the engineering and technology disciplines or who are from the science disciplines, you will agree that there is a pathway called engineering design, which is every engineering disciplines learn. how to design a system or device, right? So it's established systematic process. Then why we are discussing about that? We are discussing that, hey, look, it's time to look at it, and I think that needs some modification on how. So if you look at the user, engineering design is a systematic process. The user needs has to be identified first. And we identify the design factors, the constraints. The constraints needs to be identified. And accordingly, the design objectives will be finalized. And then we come up with pathways to achieve, to develop the solutions. We call it the design solutions. So the design solutions should match the objectives of the design. If the objectives of the design was to develop a device which will give 95% accuracy, the design solution should be able to provide. But so in this engineering design, the one key guiding factor is that the developed design solutions satisfy the given set of constraints. If the given set of constraints change, then the developed solution might not work. So therefore, it is very important to know what constraints the design factors we are developing and applying. And so from this perspective, when we look at the device industry always employ engineers and technologists. If you remember, these biomedical devices, medical devices, this industry employs people from multiple disciplines, technical graduates or engineers from multiple disciplines. If you recall, biomedical engineers or IIT Kharagpur has a school of medical technology. So they hire people from different disciplines, industrial, mechanical, electrical, material, biomedical, biosystems, similarly named disciplines, because biomedical engineering was established in 1970s. So it is 50 years, okay? But many times what they do is they learn how to apply the applicable regulatory guidelines and policies on the job, because biomedical devices are regulated industry. So it has to comply with all these applicable rules, regulation, and guidelines. So when they learn on the job, then what happens is their performance gets affected because they didn't know how to apply those applicable rules and regulations from day one. So therefore, we propose that during their education and training, they learn how to apply the applicable guidelines and policies and standards as a part of the engineering design process. We are more focused on these guidelines, for example, your ICAMR guidelines or WHO guidelines or FDA guidelines. And those guidelines need to be incorporated as a part of their engineering design from day one, not after developing the prototype and then saying that, well, now see how does it apply to comply with the guidelines. So this way what will happen, this will prepare the students to be more prepared for the medical device industries. So in the medical industry device, there is at this particular time, if you see that when the pandemic level came on, some of this kind of threat comes, there are two parameters, speed and precision. So we have to develop the device fast, but whatever we develop, it should be precise and it should fulfill all the constraints. So look at this. FDA is the federal, we have this US FDA, Food and Drug Administration of the United States. They have information related to medical device design guidance, and this is the just a simple website you have. They have design control guidance for device manufacturers. There are many books as there. The WHO has guidelines for selecting different diagnostic tests. So they also use different criteria called assured, affordable, sensitive, and specific, user-friendly. It has to be rapid and robust, and it has to be equipment-free and deliverable to the end users. So these are different frameworks, they are there. So if we bring this framework and incorporate in the education and training component, that will provide experience for the students to learn how to use it from day one. And that way they will they will learn how to reduce the development time of the medical devices. So the suggested modifications here we have is that this is a new suggested modification for engineering design, a framework for device design. So understanding the medical devices from different region and country perspective, also their social, economical, and geopolitical perspective is also important. There is when I taught this class several years before, I have used this book called Process of Biodesign, the Process of Innovating Medical Technologies. They have a second edition. It's a beautiful book which has a nice integration of the required entities for developing medical devices and systems for real world applications. So this is just an example. This is not the only book, but this is a important platform where it has integrated even the reimbursement of the medical devices. If it is get marketed, how it get reimbursed from the insurance companies and other marketing parameters, other applicable intellectual properties and compliances, guidelines and standards. So that's a good, very simple platform, but it's a nice platform. And so when we look at the role, the medical device, we see that as we stand today, there are many emerging technologies have come up. And these emerging technologies play important role in developing point of care diagnostic or variety of diagnostic devices, monitoring devices. Many of those things, all of those things you know, you heard of, then those are electromechanical systems, Internet of Things, different sensors, robotics, artificial intelligence techniques, the informatics and the analytics, the embedded system, the advancements in biology, such as synthetic biology, all these technologies are there. And they have to be integrated for a given application to meet the general need where the point of care diagnostic or diagnostic devices will be very much needed. As we come out of this COVID-19, we don't know what kind of other infectious disease or other diseases will be there, but there will be pretty much needed of bringing these diagnostic devices available at a different level of in the society that can be used at the individual home level, at the clinical level, and you could realize that how the lack of diagnostics has created a big problem in managing and controlling the COVID-19 issue. Along with that, we believe that this COVID-19 has brought a new concept of, has popularized the concept of telemedicine. Telemedicine technology is nothing new. That was there, the infrastructure was there, the concept was there, but it has popularized it because there was a requirement of social distancing. Now the telemedicine has many advantages and also need many other technological incorporations to make it more seamless between the doctor and the patient. And so therefore there will be a lot more need of these devices and technology in the telemedicine. The future of this medical world in the healthcare management systems will be precision medicine. How can we develop medicine precise to best to the person's need? And then data and information will be very, very important. And now most of these in the past, that has been a population-centered medical devices and healthcare management. It will be more individual and patient-centered so that the healthcare or disease management can be done more effectively. So these are some of those opportunities in the present and the future, and these are some of those technologies which are potential. Now, when we bring all these technologies, do you think all the students can learn all this technology during their bachelor's or master's? It will not be possible. But so what we do as the university educational systems is basically teach them how to learn so that they become, they go on appreciating the lifelong learning process of learning new technologies as the requirement develops. And that is what is going to change. So, in the role of emerging technologies, when the emerging technologies are coming, you will see that 5 years before, 6 years before, or 10 years before, if you develop an app for healthcare application, their compliance was different. And today, if you develop an app in compliance is different. So the policy and guidelines of this incorporation of the emerging technologies are also changing. And if you go back to this website, there are a lot of informations are emerging, and you can go to other websites or places like ICMR. I have not done much research at the Indian Council of Medical Research side, how their guidelines are changing to incorporate these new technologies. For example, software will be considered as a medical device. So now, when you develop the electromechanical systems, you bring these electronics, and we have sensors, and we will have embedded systems. So those things will have hardware and software component. So we have to take another new look at how to comply with these policies in this digital health domain. And artificial intelligence will play an important role. Okay, and I wanted to give you that part that they need to incorporate from the day one. This is the things from my experience which I've seen, that when we develop medical devices, they are the devices, the design from the day one, the design starts. We need to incorporate all these applicable policies, guidelines, constraints. Then only the design solution will be very successful. Okay. One use case I wanted to say is, for example, ventilator. You all know that ventilator created a big news in the COVID-19 because there was a shortage of ventilators. Was the technology so difficult? What was the problem? If you really analyze the issue, that there is assumption that ventilator will not longer be needed for that in this era, but until this COVID-19 came. So what happened? If you look at variety of parts of the world, there are multiple disciplinary efforts and teams came up to develop variety of ventilators. And we'll put that in our paper, but the ventilator, some of the ventilators have come back from $10,000 price to $1,000 price, and I see that a report from IIT Mandi, that they have developed a low-cost portable ventilators. There is a ventilator from Italy, which cost $70, use Arduino. If you know, Arduino is a hobby electronics. So what we wanted to look at is, can we use hobby electronics devices to develop a medical devices that will control, be used as a therapeutic or disease management device? That needs to be carefully analyzed. It can prove the concept of working principle, but can it be used? What are the other parameters we need to use when developing? So in that case, if you are using Arduino as a ventilator, it is an embedded system. Or if you are using a smartphone along with the ventilator, it is an embedded system. Then we need to understand what is the response time, how fast we can stop it, and all these parameters, of course, the designer must have designed. But when you put it, bring the cost down using a hobby electronics, what is the validity and what is their safety, reliability, robustness, that needs to be also analyzed. So this part, we need to look at that both from interdisciplinary convergent domain. If you look at the convergent concept, has become relatively popular in the recent years. National Academies of Science, Engineering, and Medicine in the United States have conducted many initiatives and studies and workshops to promote the convergence. And convergence basically implies that it is an interdisciplinary or cross-disciplinary initiative. But we believe that our analysis indicates that both in education research, to train our people to work in these medical device domain, they need to be trained in interdisciplinary and convergent domain. One of the key parameters in the academia, we see that when we train our people in the educational setting, in the classroom setting, and the problems are given, the problems are defined. We give the problems are mostly defined or partially defined, but what we need for the future is that we need to also train this part of called self-initiated problem identification. We need to identify the problem with least supervision from others, and that is an important characteristics for our future workforce, that they will be able to identify the problem. If they can identify the problem early, many people can observe it, but can they identify the problem and work on it, they could be the leader in this domain. Okay. So another similar characteristics is that your ability to identify the problem from redundant or incomplete information by working with the stakeholders. How can we identify the problem? Because we believe that solution of a problem, the identification of the problem is 50% of this developed solution. And this is the time where we need to emphasize that how can we identify the problem quickly, correctly. And our students, our future workforce need to also learn to work in a multidisciplinary domain or cross-disciplinary domain. That means they need to be able to project and assess a given problem from multiple perspectives, from a living system perspective. For example, if we in American Medical Association, when they recruit medical graduates, previously they were only focusing on physics, biology. Now they have combined physics and biology, so they call it physical biology. They call it chemical biology. Okay, so that means trying to define redefine the problem from the physics perspective within the biological domain. So understanding that is problem based on my experience working with multiple scientists and variety people from engineers, multiple scientists. I find out that it is very important we can realize that different disciplines
So, Professor Panigrahi, so please, within 5 minutes, please end your lecture. 5 minutes. Okay.
All right. Thank you. So, from different disciplines, it needs to be identified. So, if an engineer is working with a biologist, engineers need to be able to define the problem from a biological context. And also we discussed about that design solutions should be compliant with the regulation and policies. The key component where we have seen that our workforce needs to be aware of what assumptions are being made in the design. If they cannot identify what assumptions have been made, then we cannot know where it can go wrong. In our educational system, many times assumptions have been made, neglecting the frictions or neglecting these parameter A or B, let us solve the problem. But those cannot be done in the real world devices. This is the most important parameter. And that brings to another question of associated foundational principles. Our developers need to understand the solution is based on which foundational principles. As you are hearing from some of these CEOs who are hiring the people said, we cannot just have people who can go to GitHub or repository to find a solution because it worked on A, it should work on B. We cannot do that. That thing cannot work. So because many times this translation or transplantation might not work. And in medical devices that is not a good idea, because you need to always look at the solution and which foundational principles is working. When we have a lot of technology, we cannot assume that technology can always solve the problem. It cannot be technology push. It rather should be solution focused or solution pull. What a given solution is taking. We don't have to have a robot to cut an apple because robot is there if a appropriate technology of knife can cut the apple. I'm just giving a simple, regular, everyday example. Okay, so from this perspective, I am trying to. We are trying to put another lesson from medical education. All of you, some of you are probably doctors, or some of you have doctors, brother, sister, father, mother, or relations. But you know what? In the medical education, they first become a generalization, then they do specialization. In India, when they become MBBS, they don't come out. They are trained to treat a child, to treat people with different diseases, right? Okay, they don't become a cardiologist or dermatologist right after MBBS. So MBBS is a generalized platform, and after they do specialization. Okay, in US it's the same thing. When they finish the doctor, they are ready to work in a general domain. And when we are talking about artificial intelligence, we are trying to develop what is artificial intelligence means. Artificial intelligence means we try to make a device as intelligent as a reference intelligent device. So that's like human being. Is the human being compared to the intelligence of the human being. You know what is the characteristics of intelligent device is generalization. Can we have the artificial intelligence model able to generalize? So this is what we learn from medical education. In the engineering educations, what do? We first do the specialization. We don't create an engineer. We create a mechanical engineer, we create an electrical engineer, we create a chemical engineer. And then when they do masters and PhD, they do sub-specialization within that field. Okay, so the lesson we learn from the medical domain is that we don't have to change what we are doing, but a suggested parallel pathway for the people who want to work in the complex domain, such as healthcare domain, is that develop a general engineering, which is a generalization, general engineering with a specialization at master's or PhD level, or a general engineering with cross-disciplinary training at the bachelor level, with option for specialization, sub-specialization at master's or PhD level. So that is what we are thinking. That's a lesson we can learn from the medical side to adapt it to our engineering and technology domain. And this is, some of the universities have started doing it, and this is doable. It does not have to restructure everything, but it will give us, for example, I have found that biomedical engineers or mechanical engineers who work in biomedical domain, or electrical engineers who work they can do the electrical domain, but they don't understand the fluid dynamics. So how can they understand the behavior of the pump if they don't understand the fluid dynamics, right? But they didn't take it, so they have to rely on the mechanical engineers. So that's just an example, very simple example. So the perspective there is at the research level, we also increase more interdisciplinary, cross-disciplinary centers. There is a internal, external collaboration is needed. Those things many of you know, but key component is the ecosystem. The ecosystem should provide incentive and awards. And our feeling is that many times, even IIT has many interdisciplinary centers, and Purdue has, and many other universities has. But the name of interdisciplinary is not actually multidisciplinary. It is important that the leader of this interdisciplinary center should have experience in cross or interdisciplinary ecosystem. It is not a very good idea to take a faculty who have expertise in a discipline, single discipline, and and let them lead the interdisciplinary center. We need to accept the out-of-box thinker, and acceptance of failure as the building block for research in the global health is also important. We need to give a reference here, National Academy of Science and Engineering Medicine, which basically focused on the culture of convergence in research, and many other ideas also there. So, in summary, we believe that global health will be very critical in post-pandemic era. Global health is closely linked to the individual health. It's a two-way process. And technology will play a tremendous role in the development of medical devices and systems, but it is important to incorporate technology with the required compliance guidelines and safety. The interdisciplinary convergent pathway we discussed for education research, we believe would contribute to create a new generation workforce to contribute to the solution in the global health domain. And some of these simple solutions we proposed, they are very easy to implement. And of course, they need to be modified for a specific educational platform. Thank you very much for your attention. And again, I personally thank Dr. Manjunath and Dr. Banerjee and their team for organizing in such a beautifully technologically effective and platform for sharing everybody's viewpoint.
Thank you, Professor Panigrahi. There are several questions, but due to lack of time, we are not asking you the questions. So we'll send you the questions and you can answer them. We'll send you all the questions by email.
By email, that is indeed I will accept.
Okay, okay. Thank you very much.
Thank you.
Thank you.
This last speaker is Professor Bosu. Professor Bosu is Professor of Biomedical Material within the Bristol Dental School at the University of Bristol, UK. He has extensive research experience in material and surface engineering. He obtained his PhD in materials from the University of Birmingham, UK, and was an EPSRC awardee research fellow. His current research interests are focused on physical modulations of cell and bacteria to develop non-structural cell instructive materials and surface for smart implants and issue engineering scaffold, and also biomix, bio-inspired materials and surface with hierarchical microstructure for biomedical and engineering application. His topics is cell instructive structures, surfaces for medical implants by Professor Bosu.
He will not be physically present, his video will be...
He is not physically present. His video is uploaded here. Will be uploaded.
think we are working on that. So tomorrow it will be uploaded in the YouTube channel. I think whoever is interested in this lecture.
Okay, I will.
Also, you can ask some questions which we can, upload on the YouTube channel. So thank you all the participants for, for attending the lecture series, and we are very sorry for this video. Somehow we are not able to, run. So, but definitely tomorrow you will be able to follow this lecture. Thank you very much. Yeah, and also shortly we are going to start the valedictory session. So please wait. Yeah.
Hello participants. We are starting the valedictory session now. We are very glad to have Professor P.K. Dash with us as the Dean of Postgraduate Studies and Research, IIT Kharagpur, as the guest of honor for this valedictory session. Before I hand over the mic to Professor P.K. Dash, I just want to say a few words about the SPARK program and our activities. The primary objective of this program is to facilitate the collaborative research between the top ranked Indian institutions following the NIRF ranking and overseas research institutions following the QS World ranking from as many as 28 nations. Through this joint research project and visit of faculty, scholars and students. The final objective of this program is to address and resolve the socially relevant problems for the country. COVID-19 is one such massive challenge that requires a collaborative effort of a holistic manner to address. The present conference, mission, nano, biotechnology and even forensic science. And finally, humanities and social sciences that contributes to the social well-being of a nation. The submitted proposals go through a transparent, fair, but rigorous review process. A sectional committee with a sectional chair from each thrust area get each project proposal reviewed by 1 or 2 domain experts selected from the various institutions across the nation. Based on the reviews, the domain expert and sectional chairs make a recommendation for shortlisting, which is subsequently verified again by a committee and finally selected for and monitored by the Apex committee. During the first phase started in 2018-19, about 390 projects of a grant worth Indian rupees 251 crores were approved. Along with their chosen overseas collaborators, faculty and researchers from as many as 78 Indian institutions and universities involving IITs, NITs, IIMs, ISAR, IISc, and various university and institute specialized on different domains as mentioned earlier have SPARK projects. In the area of healthcare, as many as 20% of the projects are running in institutes like All India Institute of Medical Sciences, Institute of Liver and Biliary Sciences, and many others. Till now, 100 collaborative niche courses and 50 focused workshops have been conducted, 78 joint articles and several monographs have been published. Being the national coordinating institution of the SPARK mission, IIT Kharagpur is dedicated to ensure its successful implementation and determined to take the program forward to an even greater height. Operating under the leadership of Professor V.K. Tiwari, Honorable Director, the members of the SPARK team at IIT Kharagpur are Professor Adrijit Goswami as Joint Principal Investigator of the project, Professor Rintu Banerjee, the Conference Convener and Nodal Coordinator of SPARK for Australia and New Zealand, Professor PBSN Murthy as the Nodal Coordinator of IIT Kharagpur, Professor Jai Krishna De, Professor S. Ramanujam, Professor Shomik Shural, Professor Sanjeev Kumar Srivastava, who has been supervising all the online technical sessions for this conference, and myself. On behalf of the SPARK team, I express my sincere thanks to SMST faculty members, Professor Chatterjee, Professor Dhara, Professor Manjunath, and all the faculty members, and my humble gratitude to all the participants from SPARK and also from non-SPARK institutions for attending this international conference. A small request, the same way you are so far posting the questions for the technical sessions, please also provide your valuable feedback now about the event in our online channels and social media platforms. Your feedbacks are extremely valuable for us to improve the future events. Those who have requested for a participation certificate, you will be contacted via email within 1 or 2 weeks' time. Thank you very much. May I now request Professor Das to say a few words about the conference.
So, thank you. Good afternoon to everybody. So, we are coming to an end and the valedictory function of the International Online Conference on Emerging Trends in Healthcare Technology in Post-COVID-19 era. So, this conference is unique in many sense. It is one of the and probably the first international online conference in this campus. As on the inaugural session, Mr. Khare, the Secretary of Ministry of Education, mentioned that after the national education policy which has been declared just recently, this is the first international conference after that. And the big initiative which our MHRD and now Ministry of Education has taken, which is called SPARK for International Collaboration, which was earlier only for exchange of faculty members and some courses, but now it has expanded for research collaboration also. And as you have heard that it is for many countries, so for that SPARK, this is the first conference which was a mandate that it should conduct 2 international conferences. It is one of them. As I can understand from the from the persons who are deeply involved in organizing the conference, that this is a very unique experience because we are doing for the first time an international online conference. I do not know the current number of participants, but I hope whatever I have heard earlier that probably it has crossed 1500. And this was not possible if we could have gone for a physical conference in lieu of this, if the situation would have been normal. So, handling 1500 plus participants from different corners of this globe, this is no mean job, and our team has shown that they are capable of doing it. As far as the versatility of the conference is concerned, I have gone through the abstract list and the book which has been released, the abstract book, and the list of list of the presenters, etc. So in the list of the presenter, we could see obviously It is a it is a conference basically on healthcare. So there are practicing doctors, there are teachers of medical sciences, there are engineers, scientists and technicians, and even there are management gurus. So that shows that the conference has been able to capture almost all sphere of life, all sphere of professions which are important for the medical profession today, for modern medical profession today, particularly when we have faced this challenge of the pandemic, and we have to be prepared in future that we can tackle these kind of challenges more comfortably. The topics which I have seen, they are also very varied in nature. Some of them are particularly focused for COVID and post-COVID kind of medical care, and some of them are of general nature. Some of them are of policy based. So obviously it is a very well chosen basket of knowledge which this conference has created. And due to this online conduct, I mean, though I have not inquired, but I am sure that full recording of this conference is there. So obviously those like me who are unlucky that we could not attend all the sessions, etc. So we will be benefited by this whenever time permits. Some of our students who were not understanding what is the significance of it, or due to several reasons could not attend it, so they will be able to attend this one. So that way I congratulate the Spark team. I also express my gratitude to all the contributors, session chairs, participants, and behind the screen who helped in organizing this. So this is a new milestone all of you have created for our great institute, and we will look forward to go ahead as my previous speaker has mentioned. And I wish, or I expect that good amount of interaction you have got, you have made certain contacts so that which will be useful in future, and obviously whatever contacts you have got, you will have some future interaction, and in my opinion the conference is more than successful. So thanks to all of you.
Thank you very much, Professor Dash, for your motivational words. We are really feel very honored and proud to have a part of this conference, and it's a complete teamwork that we have followed, and thank you very much. Now I invite Professor Manjunath, the co-convener of this conference, to say a few words.
Good evening, good afternoon, and good morning, wherever you are. So I would like to summarize the activities that we have carried out since yesterday, the two-day program on emerging trends in healthcare technology in post-COVID-19 era. We started with the imaging post-COVID-19 era by five fundamental qualities that are essential for everyone involved in healthcare system. These are the intellectual humility, selfless service and dedication, agility to adapt new ideas or new habits in the post-COVID time, and emphasis on real education to impart civic discipline, and also to build the awareness in hygiene. These are all necessary across the people and across the globe. Then we started with a series of talks on tissue engineering and biomaterials, and here we touched upon the polymer and composite based printing combined with digitally acquired data using an advanced imaging technique. So these allows us for the production of personalized custom scaffolds that precisely fit specific oral defects. And that followed by cell intrusive surface for the medical implants, and in this we try to cover the cell intrusive properties together with the ease of fabrication of the nanostructured surfaces using the which holds a great promise for the fabrication of smart implants. And then we touched upon several topics related to the development of biosensors for point of care applications. Here we proposed this optical fiber based sensors as well as electrochemical impedance spectroscopy based sensors. So these were mainly developed to detect the bacterial and viral infections, and it has also been proposed these two devices or the sensors could be exploited beyond SARS-CoV-2 virus. And followed by RT-PCR, a simplified version of the RT-PCR that is that has come up with the group of team from IIT Kharagpur, and this is a low cost alternative to RT-PCR machine, and this particular device has a specificity of detection which has also been validated by taking clinical samples of COVID-19 samples as well as influenza A samples, and further trials are going on in this era. And the next we touched upon the role of radiology in COVID-19 diagnosis. So here the main aim of the countries the world over is to isolate and minimize the spread of disease and to treat these affected and with strict precaution to minimize the complications to the patient and disease in healthcare workers. Here we touched upon two biomarkers that is developed using this radiological method. So one is the supervised method, other one is a unsupervised method, and this supervised methods are basically using artificial intelligence technique. So this AI based imaging biomarkers being used for predicting the prognosis of the patients with interstitial lung diseases as well as coronavirus disease 2019 COVID-19. And these biomarkers were developed based on the deep learning of chest CT images. And followed by that, the two techniques that were proposed, one is U-radiomics and the other one is PICS to serve technique. So these are the, this is a conditional generative adversarial network. It's called CGAN. So these two biomarkers were developed based on the chest CT, and that could be used for identifying the COVID-19 patients, which is going to be a great tool in future for diagnostic purposes. So to summarize this study, the CT chest has been demonstrated and also it plays a vital role in the early diagnosis and management of COVID-19 pulmonary manifestation. And further to this, a data-driven modeling for precision medicine was also discussed. And here a case study on major depression, treatment of depression was discussed here. And further to this, the potential application of plant science in fighting viral pandemics. And in this, the application of plants can have a very key role during this critical time of COVID pandemic. And this COVID-19 outburst is mainly due to the ability of this virus to recombine, mutate
block the immune system of the host cells and infect multiple species as well as the cell types. So the plant-based medicine have an immense potential to target different stages of viral growth pathways and can be used to manufacture reagents in a time frame of weeks or even a month's time, as compared to several months or year in a conventional cell-based systems. So India has predominantly relied upon plant-based medication under different domains like the Ayurveda or other Siddha or homeopath domains. And as you already know, the Himalayan forest are abundantly flourished with rich medicinal plant species. So these will certainly boost with the diverse secondary metabolites that exhibit antiviral, anti-inflammatory and antioxidant properties. So and lastly, but not the least, is the biosafety in post-COVID era. So many several precautionary techniques were presented by the speaker, and also with reference to the WHO guidelines on how the biosafety has played not only in the clinical sector but also in the research laboratories. So as per the WHO guidelines, the essential concepts are hand hygiene, appropriate use of the PPE, then safe disposal of biomedical waste, then the environmental and cleaning and disinfection, and lastly the respiratory hygiene and cough etiquette. So these are all the essential guidelines that one has to follow post-COVID. Then the hospital staff need an adequate training at the induction and at regular intervals, so that they should be ready to be at place in calamities like COVID. Lastly, one has to have a positive attitude in the healthcare system that will do wonders. The positive attitude portrayed by the doctors is very essential, and it lays the foundation of recovery of the patient immediately after his first meet for the diagnosis. So the nursing and other supporting staff should also play an equal competent role in creating this compassionate and conducive caring climate in the common and uncommon nature, that is the COVID or any other such pandemics. So with this, I like to conclude that the emerging trends that we have studied for the past 2 days, went through the past 2 days lecture, would give a new normal to all of us, so that we try to inherit these policies that the WHO has given for the well-being of all across the globe. So I thank all the participants, and I hope all are all have got the benefits out of this 2-day seminar. Thank you.
Thank you very much, Professor M. Manjunath, for the nice summary and your thoughtful insight about the detection and treatment of this pandemic, and the different technical sessions conducted under this conference on healthcare technology and post-COVID era. You have very nicely portrayed in a brief manner the gist of the conference theme. Now I would invite my colleague Professor Sanjeev Kumar Srivastava to deliver the vote of thanks.
So I feel a great honor to deliver this vote of thanks. the convener of the conference has given me a time of ranging between half minutes to 15 minutes. I will try to stick to that. Okay, so in order, for the sake of completion, I would like to thank the Secretary MHRD, Sri Amit Khare, who has been our chief guest and patron-in-chief of this conference, and who has inaugurated the session. Our director, Professor V.K. Tiwari, who is the patron of this conference, the deputy director, Professor Bhattacharya, the registrar, Professor Singh, for the inaugural session, and Professor Das for both the inaugural and valedictory session to come here and encourage us. I don't have a hierarchical kind of address for the Thanksgiving. So I start with thanking the keynote speakers, Dr. Partha S. Ghosh, Professor Hiro Yoshida, Commander V.K. Jetli, Professor Bosu, and Dr. Suranjan Panigrahi for their motivating talks, or with talks with deep technical details made extremely simple to understand. Then I would like to thank our invited speakers, all of them. And from their talks, it was clearly apparent how much extraordinary effort and wholeheartedness they have put to make their presentations perfect for this occasion. And they presented with utmost sincerity. All the presentations were clearly understandable to a wide audience. However, we had some glitches, like in the case of Dr. Susmita Raychaudhary from Kolkata. There was problem of stuck slide, but the presentation was so beautiful, it was appreciated by many over phone to me in the evening. So they were just missing the slides. So apologies to her. Like Dr. Nazirpur, he also had the problem of the stuck slide, and we apologize for that also. These are technical glitches which we could not manage. Professor Ramakrishnan and Dr. Sudeepa Bhattacharya, they had to deal with the acoustic noise, bad noise, and we apologize for that. Then the third batch of thanks goes to all the participants. So the overwhelming response to call for registration made us nervous, with an enhanced worry to run the event with minimum flaws. And the active participation of all the participants with very, very relevant questions, it was very encouraging, and we thank them all. Then I would like to thank the session chairpersons. So I will not take all the names individually. All the faculty members of IIT Kharagpur, I would like to thank them. Especially the doctors. They are very important and very strict species on earth. I thought by calling them, I will have some closeness. So I advised, or I requested for them to be called. And to Dr. Seema Roy, in the hospital, when she is coming, I keep a very large distance to her because I am so fearful of her. But here, what I could find out ultimately, that she is so affectionate. She stayed here for both the days, for the full sessions. Both the days she was here, and it was very nice talking to her. We could also pull Dr. Som. He is very difficult to reach in the hospital. So sometimes I go there, and it is very difficult. He is more difficult than Dr. Seema Roy, because he speaks very less, very little he will speak, and he will not talk, see towards you, and then it becomes so I thought maybe we will pull him here, and the success is that I could see him laugh here for some time. Okay, I wanted also Dr. P.K. Shanigrahi, somehow he could not come. Then the fourth one to all the PIs and who were part of basically this program. Then next is the technical support. So I would first like to thank Mr. Shiv Shankar Das, who basically guided us for all the technical things. And also I would like to thank Mr. Anirban Viswas from Alumni Affairs section, who provided us the WebEx credentials for having this seminar. I also like to thank the whole team of this CET, Mr. A.V. Ramacharyalu, Kumar Abhishek Chandra, Manvendra Das, Suman Sarkar, Devapriya Chakravarti. We did have difficulties, but this team was swift in action and did their best to solve the problems without showing any kind of even slightest irritation, even if the problems were from the organizer's side. So I really appreciate their effort. I also like to thank the supporting team, Ajay Malik, Kajol Guha, Swapan Rana, and Lennis Thomas. And I would also like to thank the caterer, Suman. She will come. She will come. No, she is there. Okay. Then, as I said, this is not in order. Okay. So, I would like to thank for formality once again the Institute administration and supporting staff for the necessary infrastructure, and all those who extended support in any direct or indirect form. Now we come to the organizer's side. Okay. Now I come to the organizer's side. So first, maybe I would like to thank Devatri. She has been very dedicated for any kind of official assistance whenever it was required. So we relied on her, and we always were very happy with her work. And also Anupam Roy, I think. Anupam Khan, and who has been a workforce always from behind, and he did a lot of things for the Spark website for this conference. Then I come to the main organizers. So I will first thank Professor Manjunath for taking lead in building up the structure of the conference. He contacted he arranged the contacts to all the speakers and everything he arranged, and he is so nice doing this. And I came to know yesterday that he had been continuously helping solve even the technical problems, sitting very quietly on the back benches. So this was a great help to us. I would like to thank the whole SMST. I would not like to take names individually, but I would like to thank SMST, the whole SMST school for the assistance, and actually for being a part of this conference. Then comes the Spark team. So we are the Spark team members. So first I would like to talk, so I cannot thank the Spark team, okay? So I can just tell what we people have done. So Jai Krishnadai, he used to give very constructive comments and pointing out crucial shortcomings, and that was very helpful in shaping up the program. Then Professor Ramanujam, very particular about minuting the discussions, really helpful afterwards, very critical yet constructive suggestions. Third, Professor Debalay Chakraborty, a silent machine. He suggests the things perfect and does the thing perfect. And this has very swiftly taken us to this stage. Fourth, Professor P.V.S.N. Murthy. So initially it was difficult for me to find out how many words are there in his name. So now I have counted. Okay. Apart from giving fatherly guidance for the whole conference, he has been very meticulous in writing the drafts. Like he says, you see, the alternate words in the title should have larger and smaller fonts. So this kind of meticulousness he has. Fifth is Professor Adrijit Goswami. You go to him with a problem or a plan. He will say, okay, I don't know, you have to see. And you get nervous. And the next day, you will find that everything has been done already. So that is the kind of work he does, that is the kind of guidance he gives. So this is our team member. Then Professor Rintu Banerjee. She took the responsibility to convene the conference very readily when it was proposed. I was nervous, but what I have learnt in these days is that she knows some black magic. It was that day when she took the responsibility, and now it is this moment when the conference is just to conclude. She just gave some smiles and cracked some jokes, and the conference is over. So this is the kind of caliber she has, and hats off to her. Then the most important team member, the director, is the main guide. I had a few meetings with him for discussing several issues or problems. What I have realized is that if he somewhere during the discussion starts with, "Arey bhai," you must assume that the problem is solved. So that is the kind of leadership we have with us, with the Spark team and for the institute. About me, I have only created difficulties. All the technical issues for which I was given the responsibilities, there are a lot of problems, and I take all the responsibilities for all that. At the end, I would like to thank all those who extended their cooperation and support for what we feel has been the success of this conference. So thank you very much. And with this, the conference is concluded. Thank you very much. Thank you all. Thank you all the participants.